Hi, this is Adam Griffin, and this is the first video for this week, which is week 3 for the physics videos. So this is problem 44, and the problem is a spaceship maneuvering near planet Zeta is located at 600I minus 400J plus 200K times 3 to the third kilometers. And the R vector will represent our position. So that's relative to the planet, and it's traveling at a velocity of 9,500 meters per second in the positive I direction. So that's this way, going towards this positive I. And it turns its thruster engine on and accelerates at 40I minus 20K meters per second squared for 35 minutes. And I will get rid of this box by clicking on that cursor. So we need to find the position once the engine shuts off after going for 35 minutes. So we can look at where our initial position is. So it's 600. Here, let me scroll up a little bit. It's at 600I, which is right here, minus 400J. So pretend that this axis is going back into the page. So we go backwards 400 units, and then we can meet it right there, and then it's at 200K, so we just go up along the K axis 200 units. So that is our initial position. So our velocity is 9,500 meters per second going in the positive I direction. So this orange will represent our velocity, and our acceleration is going 40 in the I direction and negative 20 in the K direction, so that's down along this blue axis, for meters per second squared for 35 minutes, which is equal to 2,100 seconds. So we have our equation for our final position using our initial position, which is this R vector, plus our initial velocity, which is 9,500 meters per second, times the amount of time that has passed, 2,100 seconds, plus 1/2 of our acceleration, which is this right up here, times the amount of time that has passed squared. So once we plug all of that in, it's kind of long. We can rewrite this 10 to the 3 kilometers as 10 to the 6th meters, because there are 10 to the 3 meters in 1 kilometer. So we'll just rewrite it like that to keep everything in meters. So we now have our initial position plugged in, our initial velocity, and our acceleration, and also our time for both of those. So we plugged everything in, and now I put everything into kilometers. So times 10 to the 3 kilometers for everything. So this gives us 600I minus 400J plus 200K plus 19.95I plus 88.2I minus 44.1K. So if we do all of that, we will get 708.15I minus 400J plus 155.9K times 10 to the third kilometers relative to planet Zeta. So we can see that the reason that we multiply velocity by time is because for every second that passes, which is 2,100 seconds, it will travel this far in that direction. So that is pretty explanatory, self-explanatory. And then for the acceleration, this is the same as distance equals 1/2 of g times time squared, which we did in the lab last week. So in this case, the acceleration is not g, and it is a given acceleration. So once we get all of that together, this is the final position in terms of these coordinates. So that is how you do number 44, and thank you.